Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 20C, area of circles. Let's start with the first sum. The diameter is given as 28 centimeters and we have to find the circumference and area. Now, we can find the circumference by the formula 2D, that is 2 into diameter. Or we can use the formula 2 pi r. So I will find the radius first because that is required to find area anyway, because area's formula is pi r squared. So do not be confused between these two areas, these two formulae of the area and the circumference respectively. This is 2 pi r and this is pi r squared. There is no 2 out here and there is no squared out here. So radius is half of the diameter. Circumference formula, pi's value we always take as 22 upon 7. Only if in a question they mention the value of pi as 3.14, only then are we allowed to use that value. Otherwise by default it's always 22 upon 7. Remember, the units of circumference is in one dimension, that is centimeter. Like perimeter, it is also just centimeter or meter. Area, on the other hand, it has units in two dimensions, that is centimeter squared or meter squared. By the way, the volume unit would have been centimeter cube or meter cube. So that was the first sum. Now in the third sum, the sum of the circumference and diameter is given and we have to find the radius. So if circumference plus diameter is 116, use the formulae. Remove 2r common, so what is left is pi plus 1. Substitute, do LCM to get this and cross multiplication, send everything on the other side. 7 goes up, 29 goes down. I want r alone and I get the value as 14 centimeter for the radius. In the fifth sum, the radii of two circles are given. Find the area of a third circle whose circumference is equal to the difference of the circumference of the first two circles. So always read the question carefully before solving. So mathematically writing, the circumference of the third circle is equal to the difference of the given two circles. So the formula 2 pi r is equal to pi r1 minus 2 pi r2. I can remove 2 pi common here and then 2 pi can be cancelled. So what is left is the radius of the third circle is radius 1 minus radius 2. Obviously radius 1 will be bigger. We don't want negative answers. Substitute the values and get the radius of the big circle, or rather the third circle. It's not the big circle, it's a third circle. And then using that value we can find the area in centimeters squared. So 7 ones are, 7 fives are, and then multiply these. Seventh sum. The radius of a circle is 5 meters. Find the circumference of the circle whose area is 49 times the area of a given circle. Read this twice to make it very clear. So we open the statement with the fact that the area of the second circle is 49 times the area of the first circle. That is what is mentioned in the question. So pi r squared is equal to 49 times pi r squared. Pi and pi will be cancelled. Substitute the value of r as 5 given in the question. So 5 squared is 25. No need to multiply it. You can directly find the square root of this. This will be 7 and this the square root is 5. 7 into 5 is 35. That's the radius of the new circle. Find the circumference of this new circle. That's what they've asked to find, and that's how you solve it. Now in the ninth sum, this is a square ABCD. It's a square cardboard. And the side is 28 centimeters. So 28 is the side. 4 identical circles of largest possible size are cut. That means they are touching each other and touching the sides of the square as well to minimize a wastage in between them. What is the area of the remaining cardboard? Well, that would be the area of the square minus area of the 4 circles. Area of the square would be side squared. That's 28 squared. But to find area of a circle, I need the radius, which is not given directly. Now notice how this diameter plus this diameter is equal to 28. So I can say that r plus r plus r plus r, the sum of these 4 radii is equal to 28. That means radius must be 1/4 of 28. So once we find the radius, we can find the areas and the sum would become easy to solve. You should draw diagrams for each sum in math, especially when the diagram is given. You can even show markings like I did in the textbook, drawing the radii and the diameter, etc. So side of the square is given, we find the area of the square first. Please mention whose area you are finding, because we've got multiple diagrams, multiple shapes in this sum. Radius, as I said, was 1/4 of this side, so I got the radius, so I can find the area of one circle, find the area of 4 circles, and area of the remaining cardboard is the difference between the areas. In the 11th sum, the ratio of the diameters is given and the sum of the circumferences is given, and we have to find the difference between the areas of the largest and the smallest of the circles. To find the areas, I need the radius. So we are going to use the given data to find the radius. Well, interestingly, the ratio of the diameter will be the same as the ratio of the radii, because 2 gets cut. Whenever ratios are given, what do? We assume a common proportionality as, let's say, x. So R1 is 3x, R2 is 5x, and R3 is 6x. Now it's also given that the sum of the circumferences is 308. Now using the formula, we get this equation. We can remove 2 pi common and substitute the value of pi, and also of R1, R2 and R3. So the only unknown variable in this equation is x. So you solve it to get the value of x. Please don't just copy from here. Actually do the cutting, the reduction, the multiplication, division, and get the answers. You all need practice in math, so that once you're well versed with these sums, you can very easily do the remaining sums which are of the same type. You need to invest your time and effort in understanding these sums and the remaining sums. I'm sure you would hardly have any doubts left if you do the way I say, especially after having practiced the solved examples as well. Even there, don't copy, understand it, so that whenever there is a test on this chapter, you will find it very easy to solve and get good marks. After finding the value of x, we can find the radii, but we'll just find R1 and R3, not R2, because all they want in the end is the difference in the areas. So pi common, R3 squared minus R1 squared. R3 is clearly bigger than R1. We can use a decimal value as well here, but I prefer the fraction. And no need to square such big numbers, although you can. I prefer the method of using the formula a squared minus b squared is a plus b, a minus b, because that will make the calculation simple. You find the radius out here and then you cut whatever can be, multiply, divide, and get the answer. It's in centimeters squared. Now the 13th sum. The circumference of a given circular park is 55 meters. Well, from circumference, what can we find? The radius. It is surrounded by a path of width 3.5 meters. Find the area of the path. Getting the diagram right here is very crucial. Is the path outside or inside? Well, it's given surrounded, so it will be outside. That means the circumference of the smaller circle is given here, 55 meters. So we'll find the smaller radius, which is 8.75 meters. So small r we have found, and the width is 3.5 meters. So what will be the total radius of the big circle here? It will be addition 12.25 meters. And area of the path, well, we use the formula of area of a ring, which is big circle minus small circle and pi common. Again, after substituting the value of r and small r, we can use a formula a plus b, a minus b, which will make calculations easy. And then of course 7.5 ones are, 2s are, 11s are, and the answer is 321 meters squared. Now mark the 15th, the 21st and the 25th sums as IMP, so that whenever there is a school exam of this chapter or many chapters together, you can practice these IMP sums at least. In fact, if time permits, you should solve all the sums again. That's the way to acquire mastery of math. But the IMP sums at least are the minimum homework, which is absolutely compulsory and essential to revise the chapter quickly. The wheel's diameter is given, and we've been asked to find the number of revolutions to cover this distance. Now note that when a wheel or any circle completes one revolution, the distance traveled by it is equal to its circumference, because when the wheel makes one revolution or one rotation, it goes forward by a distance which is equal to its perimeter, which is nothing but the circumference. So in such sums, always keep one point in mind, that distance covered in one revolution is equal to the circumference. So that's the first thing I'll find out, the circumference. Note how I didn't find r first, because I could directly find circumference using this formula, 764 centimeters. Now the distance given in the question was in terms of kilometer, but this is in centimeter, so we'll have to convert it. I find it easier to convert kilometer to centimeter rather than the other way around. So here I go. Into 1000 will give me meters, and into 100 will give me centimeters. These many centimeters. Now we'll use unitary method. 764 centimeters are covered in one revolution. This is the circumference, by the way. So this much distance will be covered by x revolutions. Cross multiply and get the answer, which is 1200. 17th question. An express train is running between two stations with a uniform speed. The diameter is given and the number of revolutions are given per minute. What is the speed of the train? Well, speed is equal to distance upon time. Time is 1 minute, that is 60 seconds. Distance is something we'll have to calculate. What we'll do here is, since we know the diameter, we'll find the circumference. Circumference is the distance traveled in one revolution. Totally there are 1200 revolutions. So we can find the total distance, and then total distance upon time will give us the speed. So that's the logic we are going to use in this sum. But speed is usually expressed in kilometers per hour or meters per second. I will choose to solve in terms of meters per second, the SI unit. Although even if you get the answer in kilometers per hour, that will also be acceptable. So with the diameter, find the circumference, that is the distance in one revolution. So the total distance in 1200 revolutions will be the multiplication, which is these many centimeters converted into meters. Speed is distance upon time. Distance we found out, and time was 1 minute, that is 60 seconds. And this is the answer in meters per second. In the 19th sum, they have given the circumference of the big circle and the small circle, and they've asked us to find the area of the shaded portion. Well, using the big circle, find the big R. Using the small circle's circumference, find the small r. And then area of the shaded portion is nothing but area of the ring formula. So here I found big R and small r, area of shaded portion, substitute to the values, and please add them, get the numbers, multiply them, divide them, and get this answer by your own calculation. Shortcut never leads to success. And the 21st sum, the cost of fencing at the rate of 240 per meter is given. Now, the cost of fencing will be equal to the circumference into the rate. The cost of fencing is equal to circumference into the rate. On the other hand, the cost of ploughing would be area into the rate. But how can we be sure whether we should use circumference or area in the formula? Well, logically speaking, when we talk about fencing, we are only talking about the perimeter, the borders or the circumference. And when we talk about ploughing, we are talking about the entire area of the field. And there is a hint as well. You see, the rate here is per meter, and here the rate is per meter squared. This is a very good hint to realize that this rate is relevant for circumference and this is relevant for area. So, circumference is cost upon rate. So, using the values given, we can find the circumference, but circumference is 2 pi r, so now we can find the value of radius, which will be required to find the area, and then area into rate, the other rate, will give us the cost of ploughing. In the 23rd sum, inside this circle we have a rectangle. So it's a circle for this rectangle. The vertices are touching. The values of the length and the breadth are given, and we have to find the area of the shaded portion, which will be area of the circle minus area of the rectangle. Area of the rectangle would be easy to find, its length into breadth, whose values are given. But for area of a circle, I need the radius, which is not given directly. However, if you notice the diagonal here, AC, or even BD for that matter, the diagonal of the rectangle is equal to the diameter of the circle. So using Pythagoras theorem here, because it's 90 degrees, right? Pythagoras theorem in triangle ABC will find the diagonal AC, which would be the diameter of the circle. From that we'll get the radius, and from that we'll get the area of the circle. And then we can subtract the area of rectangle from it to get the required answer. So in triangle ABC, first use Pythagoras theorem to get the value of the diagonal AC. You'll have to add them first and then take the square root to get 35. I've done it directly, but you should always do it in the detailed method, showing all the steps clearly. You know how to find square roots by prime factorization method. So the diameter is also equal to 35 centimeters. The radius is half of that. Find the area of the circle. Also find the area of the rectangle, and the difference between the two is the area of the shaded portion. Draw the diagram, please. And the last question, 25th sum. There's a metal wire which is an equilateral triangle. Its area is this much, which is approximately 800 and something centimeters squared. Now if the same wire was converted into a circle, what would be the area of the circle? For area of a circle, I need the radius. For radius, I need the circumference. Circumference will be same as the perimeter of the triangle. For that, I need the side of the triangle. And that can be obtained from the area of the triangle. So first, from the area of the equilateral triangle, find the side, because the formula is this. Fortunately, root 3 and root 3 gets cancelled, 4 goes up. No need to multiply here, just start the prime factorization or do it mentally to get the square root as 44 centimeters for the side of the triangle. Perimeter of a triangle is 3 into side, which is 132. But circumference of the circle is equal to the perimeter. So even the perimeter and the circumference of the circle will be 132. Using the formula of circumference, now find the radius of the circle. Using the radius of the circle, find the area of the circle. Clearly, this area is greater than the area of the triangle because circle always encloses maximum area with the given length of wire. That is why it is the most beautiful figure. But that doesn't mean you should get a circle as far as your marks are concerned.